the law of cosines. And my claim is if I have the Pythagorean theorem, I get the law of cosines for free. Well, in terms of stating the law of cosines is a generalization of the Pythagorean theorem. In terms of constructing it, it's often the other way around. The law of cosine is more general than the Pythagorean theorem, and thus it is more subtle. And what we do is we build, one way to build the law of cosines is to start with the Pythagorean theorem and then build on top of that the more general case. And we'll see that in just a second. Could you guess, if we wanted to prove this, what we would start with? Yeah, let A, B, and C be as described before. Should we just remind ourselves what we mean by as described before? Yeah, suppose let's go ahead and do this. So A, B, theta was between, what was the length of the side? It's not adjacent, it's opposite. We call that opposite, right? Yeah, opposite of that was called C. So we want to prove that. I'm going to claim that there are 3 cases, one of which is done. Three special cases in terms of theta. Could you guess what those cases are? Yes, maybe we'll call case 0, theta equals 90. If I want to prove that thing, what do? I literally just drop the mic right now. I'm done. I've already done that proof, right? What's the other one?
Theta equals 0.
Theta
Equals less than 90.
Yeah, we call that acute angle because it's very fun to look at. It's acute angle between 0 and 90. Bad joke. All right. Yeah, so theta between 0 and 90. Could you guess why we don't let theta be equal to 0? Because it's not a triangle, it's a line, right? It's still useful to analyze that. It's not a bad analysis. In fact, the thing will still pop out, right? But we're hoping to stick with triangles. Yeah?
What does a solid square mean? Right after the 0, 90 degree theta.
Oh, that was me dropping the mic. We're done with that proof, right? Why are we done with the theta equal to 90 proof? If theta is 90, which triangle is that? If the angle across from C is 90, which case is that? Yeah, case of the right triangles, in which case this is called the Pythagorean theorem. Yeah, and we have a proof of that. It's a beautiful question. Make sure that I know not to drop the mic without announcing it clearly. Okay, we have 90 degrees, we have acute. Yeah, what up? What's the last one? Obtuse. Obtuse. Yeah. Could you guess what the assumptions on theta are for obtuse?
90.
Yeah, 90, not touching 90, and also not touching 180. Why wouldn't we want to touch 180? It's another line. It's a line in the opposite direction. Do you have a sense of which one you want to do first? Well, yeah, let's start with the acute one and then go to the obtuse one, right? Yeah, it doesn't matter. So let's do case 1. So we will suppose that theta acute. So the English word is acute. What does it mean to be acute mathematically? 0 and 90, which means we can visualize this. Here we go. What did we say about A, B, and C? C is the angle opposite to theta. A is one side, B is another side. Is in this visual, is theta less than 90?
Yes.
How do you know that? Because it's not a right triangle and it's definitely not greater than 90, right? Is it greater than 0?
Yeah.
Okay. Is it possible to impose a Pythagorean situation on top of this? Is there a way that you could cut this into 2 right triangles?
Yes.
What would you do?
Line down the middle.
you said to me that if I did this, and I called, I don't know what we want to call this, I think I called it H in the notes, and if that was an orthogonal projection, if it was an orthogonal projection, we could actually say something interesting, right? Maybe we call this entire length, the length from this end to this end. Do you remember what we called that based on the assumption of the problem? A. We call that whole thing A. And then perhaps we call this one right here, we call it X. If this one was X and this one was A, what would it mean about this one right there? Must be A minus X. Can you help me with the statement of the Pythagorean theorem for both of these cases? Now, we apply, I guess we would actually call Pythagoras and say, help us out. Two instances of Pythagorean theorem. And maybe we call this thing right here triangle 1, and this thing right there triangle 2. Let's look at triangle 1. What's the Pythagorean theorem say in triangle 1? X squared plus h squared is equal to b squared. What about the Pythagorean theorem in triangle 2? A minus x squared plus h squared is equal to c squared. And let's do trigonometry, trig relation. Is there any way that you could relate the quantity h back to the angle theta? Is there any way that you could help me with that? Tell me about that. Cosine of theta is equal to x over b. So let's go ahead and do that. Let's say that the cosine of theta is the length of the adjacent side divided by the length of the hypotenuse. What would that immediately imply about x? B times the cosine of theta. With these three facts combined, we are Captain Planet. Wouldn't it be nice if we could solve global warming with just these three facts? That would be pretty cool, considering most of us are the ones that actually have to deal with that problem. Right? Perhaps we can start here, though. Is there any algebraic operation that you could do right there to make that thing look a lot more beautiful? By equation 2, we know a minus x squared plus h squared equals c squared, which immediately implies what? A squared minus 2ax plus x squared plus h squared is equal to c squared. What is this? Now I ask ya. X squared plus h squared, do you know a relation about that? B squared. Oh, okay. So you're telling me that I had minus 2ax, this thing became b squared, and this was c squared. What did you know about x? We know from equation 3 right here that x is b times the cosine of theta. Everywhere I see an x, what can I put in? AB cosine of theta plus b squared is equal to, what was the claim of the law of cosines? If you can look at the punchline to that joke over there, what was the claim of the law of cosines? A lot less fun when a mathematician does it, isn't it? The crowd is just like silent. When a rapper does it, they're like, oh! Nobody understood the rhyme. I think they call that a bad rapper. Yeah.